Overview. This is my useless box project. The only input to the box is a single double pull, double throw switch. The 4 outputs, or moving objects in this project, are 2 9-gram servos and 2 high torque servos. The schematic. My Arduino of choice is an Arduino Uno 101. This Arduino is unique. You can't really buy it anymore, but for a lot of things it is still a very solid board. I chose this board for 2 main reasons. 1. Its size. It's a smaller board than my usual mega board, and for a smaller form factor it is necessary. 2. I only have a shield for the Arduino 101. A shield is a perf board that has the necessary pins and connections to attach directly to the Arduino. Essentially, I can solder on a perf board that is stronger than a breadboard, and I still have the ease of plugging in and out of the Arduino itself. There are 2 components areas of interest. The first is the servos. A servo motor is a rotary actuator, a linear actuator, that allows for precise control of angular or linear position. Basically, a servo is a motor that is exact, and we can tell it to go to an angle and it will go. There is a large variety of servos. These servos can only rotate 180 degrees. I was going to go all 9-gram servos, but these servos cannot provide enough torque to push and pull the switch. So for Mark II, I had to change up the 2 middle servos to higher torque servos. Each of the higher torque servos have what's called a flyback diode on their ground lead. When a motor turns off, the electromagnetic field collapses and causes a current spike. To prevent a spike from damaging my components, I use what's called a flyback diode. Servos have the spike too. When the spike hits the board turns off and resets. Why? Don't know. Aliens perhaps. Not my issue. Anyways, I use a diode. A diode is a one-way valve. A flyback diode is any diode connected across an inductor used to eliminate flyback. So, it fixed the issue. The second component area of interest is the switch. The switch is a double pull, double throw switch. This switch was modified by me in 2 ways. 1, I took it apart and made the amount of force required to push it back and forth less. And second, I soldered it in a way so it's functionally a single pull, single throw switch. This is my code. Pre-setup. This is the pre-setup right here. The pre-setup, I set all the pins for my components, create variables, include all the necessary libraries for the servos to work, and create several objects for the servos. So this is where I create the objects for the servo, library, and then all my variables needed for the code. My setup is fairly straightforward. I begin the serial, and then I attach the servos to respective pins, and then I make sure all the doors and arms are closed on the useless box. This is so that the robot or the useless box starts in a closed position. The main function of the code is in this while loop right here. This while loop is dependent on 2 if statements. If switch state is 1 or if switch state is 3. The switch states function operate off of the switch state. The switch state is the direction that the switch is currently flipped to, and each of these if statements are if it's to the left or to the right. The switch state is decided upon the switch state function. This is the largest function in the code, and is honestly it's larger than my loop of the code. It needs to be complicated just because the switch is difficult to work with in the Arduino. The switch is difficult to work with the Arduino, so I must use clever software to get around some of the limitations. We first start with an analog read of each of the pins that the switch inputs into the Arduino. I then reset some of the variables that will be used later on. Most of the function is dependent on this while loop. This while loop runs forever until a switch state is assigned. This if statement and this else if are practically the same. So I'll only be discussing this if statement. The if statement starts with if x is greater than 1000 and if x is greater than y. Once it enters this if statement, it increases the count of this variable by 1. When this count is increased enough times, it will then enter this if statement, which sets variables, the switch state, resets one of the variables, and breaks the while loop, proceeding to the serial printouts. This is the same business in the else if, and the else is the middle state of the function or of the switch. So it doesn't need to be as complex. And these are my door and arm state switch functions. These functions are just the position for the servos and arms, and doing it this way helps keep my main function clean and less repetitive. And that is my code. From here on out, I'm going to be going over designing, build process, and overall decisions I made for the project. So if you'd like to leave, now's your chance. First, going to start with the CADing, as this was the first step of the design process for me. CAD stands for Computer Aided Design. Engineers and degenerates like me use CAD to design and edit 3D models. We can use these files to create 3D prints of these objects, amongst other things. Before CADing an object, it is wise to create a sketch of your object, preferably one that is geometrically sound. First thing I did was create a base from which the servos will attach to. So I call it servo board. I positioned the servos, created holes for them to sit in, screw holes for them to screw into, and sketched their movements out onto the board. Then I created a basic platform from this to sit on and potentially attach other things to further down the road. Then I created the arms, trapdoors, and a switch holder. These are all Mark 1 of this project. This is the final assembly of Mark 1, and I did 3D print all of the stuff, and this was created. So I recorded this section. The audio didn't record along with it. Don't know why. Don't really care. Whatever. I'm going to re-record it. So here it is. After Mark 1, there were a few things that were immediately apparent, like tolerances and parts rubbing up against each other. The main issue, however, was the 9-gram servos in the middle could not flip the switch. So this is where Mark 2 comes into play. Mark 2 looks pretty different. So we have the larger servos on the servo holder. These are high torque servos, and they have plenty of power to move the switch around. They still need the flyback diode. Then the arms got redesigned. They're thicker, they're stronger, and they have now this little thing that lines up with the servo and kind of holds it a little better. And the trapdoors got redesigned, so they're fully out of the way of the arms. Now, this is great and all. I printed it. Nothing was a matter. But then I designed this short box around it. And this was kind of like the end game of the design. And I noticed that this clips this, and there was no way I could get it to rotate within the box and down under. It just wasn't going to work. So I was thinking about like complicated rotational to linear designs that I could have implemented. And then I had a great idea. And that's where we get to Mark 2.5. Mark 2.5 is much better. So I turned the box to glass just so you can see all the parts better and you can still see the components. However, I am going to hide this. So in this, the walls have so the shorter box, they have a cutout for the trap door to sit on. See how it just sits there? And when I rotate this, it just never touches. And that took a while to get right. But once I got it right, it works beautifully. These also got a little bit of redesign. They got moved. They didn't get shifted or anything, but just to make sure that this really wouldn't hit, I took away one of the little holders. That's why they look the way they do. And the shorter box, of course, got the little cutouts. And that is Mark 2.5. So, time to discuss the electrical decisions I made. So, I first tried everything with just the board, the way it's viewed in the schematic, because shields don't really exist in fritzing that well, or they don't have the right shield. It doesn't exist in fritzing. So I did it like this. Everything worked fine. Then I got home with, then I spent a day soldering the shield, and then I messed some things up, and I spent another half a day on soldering or desoldering and resoldering. Because it was one of my first times soldering, so there were bound things to be messed up. And I learned a bunch of things along the way. And then I got home, and things just didn't work. So I debugged, resoldered, or desoldered, resoldered the whole board twice. Things started to work. I figured some things out, like the servos really need to run at the maximum voltage you can get out of the servos or out of the Arduino, especially these bigger servos. They need more voltage at the Arduino can't really supply, but you can get away with. But yeah, that was basically it. It took a while for me to do this. If your servos aren't working, check that if you have the correct voltage. If you have the correct voltage, check for flyback, of course. And if flyback and the servo's not working, the servo could be dead, but also you could have your negative positive wrong. You could have make sure all your cables are labeled correctly, stuff like that. I also figured out the Arduino needs to run off a 9-volt battery supply. It cannot run off anything less. I tried running it off 6. The servo simply would not work. You need to run the Arduino off a 9-volt power supply. Also, the switch was giving me issues. Since the switch has such a high innate resistance, it doesn't really throw the best numbers for the Arduino to use. So I needed to filter out some bad values, and that's why my check switch state function is so complicated, is because I need to account for stuff shit like that. And this brings me into what I would change. One, I would love an extra week of coding, just to add personality and some intelligence to the box. So maybe it can start doing these projects for me. I want to focus on more important things, like dating your mother. I would also love to improve the wiring and Arduino placement. If we pull up my Fusion, so where do you see the most room here for a board? That's right, it's over here and along this wall. Guess where my Arduino is? It is shoved in the corner. I'm not showing you a picture, but it is a tight fit. I should have wired everything better, but you live, you learn, whatever. And I would also like to add some sound, and maybe the box can talk to you and tell you that you're a failure, stuff like that. So that's my project.